Today we will be covering 6-4 rational exponents. Your learning goal is that you will be able to simplify rational exponents. Now, if you can recall, a rational number is a number that can be written as a fraction. So you're going to see a lot of your exponents as fractions. And before we start, we need to go over all radicals can be written as fraction exponents. So for example, if you see square root, that's the same thing as taking that number and raising it to the 1/2. Because the 2 is your root or your index. If you see cube root, that's the same thing as raising it to the 1/3. And then if you see 4th root, that's the same thing as raising it to the 1/4. So this is good to know because if they give it to you as a rational exponent, then you need to know you can convert it back to a radical to help you out. Okay, so let's try some examples. Okay, so first thing you want to do, convert it to a radical. So remember, to the 1/3 means cube root. And what is the cube root of 216? 6. Here, I'm going to convert these to a radical. And as long as they have the same root, you can multiply them together, which will give us 7 again. Same kind of principle with example C. Anytime they have the same root, you can multiply them together. And if they're nice, it'll be a nice number, or if not, you'll have to simplify it. And that's just simplifying rational. Now, they all won't be 1/. You may have one that looks like this. I'll even do a variable. So in this case, 2 is still your root, but now we're raising it to the 3rd power. And you can either write it like this, or some people like to write it with it on the outside. So whichever benefits you, there's no right or wrong way to write it. I do want to point out or remind you now, if it's negative, if you had something like this, then remember you have to put it under 1. And then we know that this is 3 5/10, which is the same thing as 3.5 is the same thing as 7/2. So that's how it'll look if it's negative and if it's a decimal. And so that's how you simplify or convert from exponent to radical form. Okay, we need to review our properties of exponents because you're going to use the same properties you did before, even if they are fractions. And the first one, remember, is when you're multiplying with the same base, remember you add your exponents. The difference is you may have to get common denominators. When you're raising a power to a power, you multiply. When you're dividing, you subtract. And remember, we talked about if it's negative, you put 1 over that term to make it positive. And anything that's inside the parentheses and you're raising it to a power, it has to be, that exponent has to be distributed to both or all terms. Same thing with division. It has to be distributed to all terms that are inside the parentheses. And then you'll simplify it if you can. Okay, so those are the properties. Now let's practice some problems with combining and simplifying. Okay, here's a couple that I have to try. Let's start with the first one. Notice the roots are not the same, so we cannot multiply them. So I'm going to change them to radical form. So this, exponent form. So this will be 3 to the 1/2 times 3 to the 1/4. Using my property of exponents, whenever you're multiplying, you add your exponents, but you need a common denominator, which is 4. So I'm going to change this to 2/4 and 1/4, which equals 3/4. The rule is, if you change it from radical to rational exponent, you have to turn it back to a radical. So as a radical, the 4 would go here as the root. This will be 3 to the 3rd power, which is 27. And then this will be your answer. So you must remember, however they gave it to you in the problem, that form has to be the same as your answer. Same here. The roots are not the same, so we can't just divide it. So I'm going to turn these into radical form, rational exponent form. And using my properties, I would subtract the exponents, but I need a common denominator, which will be 6. And I'm going to get a negative, so I'll leave it like that. Now, because I have to change it back to radical form, be 1 over the 6th root of x. We cannot leave, remember, we can't leave a radical in the denominator, so we have to rationalize it. Well, since we need 6 x's and we only have 1, we would need 5 more in order to make a perfect 6th root. So that way we would get the 6th root of x to the 5th over x. Okay? And then for this one, remember, it's negative. And then I'm going to turn into a radical form, which is the 5th root of 32. And then whatever the answer is, I'm going to square it. Well, the 5th root of 32 is 2, and 2 squared is 4. So my answer would be 1/4. For D, I'm doing the 4th root of 16, and whatever that answer is, I'm going to cube it. 4th root of 16 is 2. 2 cubed is 8. Now for this one, it's going to be 1 over, remember 3.5 is 7/2. I'm going to convert it. Be the square root of 9 raised to the 7th power. The square root of 9 is 3. And I know that's a big number. But 1 to the 7th power, or 3 to the 7th power, is 2,187. Don't worry, you won't get one like this on your test or quiz. Okay, here's one. Remember our properties. Anything that's in parentheses has to be raised to that power. So the 8 will get the negative 1/3. And the x, if you distribute that, that would be negative 5. Since they're both negative, they're going to go under 1. Remember, that means cube root of 8, which is 2, x to the 5th. That's why it's very important to know your cubes, because you can do them even faster. Now, before I distribute the 3/2, I'm going to change the y to the 1/4. So that means 9 to the 3/2, x to the 3/2, and y to the 3/8. So 9 to the 3/2 would be the square root of 9 cubed. Square root of 9 is 3, and 3 cubed is 27. Now, if you notice the x and the y don't have the same root, but I'm going to make them the same by changing this to 12/8. That way, when I put them back in radical form, the root now is 8, so that's x to the 12th, excuse me, and y to the 3rd. Well, this can be simplified because if I have 12 x's and I'm grouping them in groups of 8, that means one group comes out, but I'm still left with 4 more x's and then my 3 y's. So that one was a little tricky. And then you're done.